Hello everyone, my name is Chetan and welcome to the module 4 of my training session. So in this module, we're gonna talk about what is inheritance, then what do you mean by interface, difference between overloading versus overriding, what is an object class, why it is called a superclass, then how this inheritance or interface is useful from a Selenium perspective. We also gonna talk about what do you mean by abstraction. Then what are packages? Why do we create packages? And how we can access classes across multiple packages, right? So let's get started. So as you know, in the module 3, right, we talked about what is class, what is object, then instance versus static, constructors, and so on and so forth, right? Now I'm gonna create a package with the name of inheritance. Okay, so let me create a package inheritance, right? Now let's close these programs first. Okay, now in this package I will create a very basic class called as car, right? Now this car has something called as name, then it also has, let's say, model, right? Now so this is nothing but global instance variables, whereas this is something instance methods. Okay, so in case of an instance method, I'm gonna something I'll say public void start, right? And I'm gonna put this out, let's say, just a second, oops, syso, just say control space, and I'll say this is car start. Then I'm gonna create another instance method, let's say mileage. Okay, and here I'll make this mileage as a very generic one. For example, it is 12 kilometer per hour, okay, per liter, sorry. Okay, now now as we know, so this is a car structure, okay, this is a car class. Now in this car class we have two global instance variable and two methods. Now let's assume I have another class called as BMW car. Okay, now if you notice here, so let me draw two objects, right? So let's say this is my car, and then I have something called as BMW car. Now this BMW car, let me write down some text here. Let's say this is BMW car, right? Whereas this is my car, right? Now this BMW car is also a car, right? And this BMW car will also have a name, will also have a model name, it will also start, and it will also have a mileage, right? So rather than creating BMW car class separately, or rather than defining BMW car from scratch, what I would prefer is to inherit the existing car design in this BMW car. Okay, so if I try to show this pictorially, so it means basically, just let me search for a line basically, just a second. It means, guys, okay, so this BMW car basically is extending basically this car class, right? Just a second. like this, right? So so the arrow should be towards the car class, because BMW car is extending a car class here, meaning whatever whatever instance variables and instance methods this car class was having, now those will be inherited by this BMW car. To give me a simple example, for example, we as in the whenever we, like for example, we inherit some properties of some features of our parents, right? We always say like that, right? So in this case, BMW car is basically extending a car class, right? So when a class extends another class, so this becomes basically, I'm sorry, I wanted to write down some text here. So this becomes a subclass, also known as child class. Okay, whereas this car class becomes a base class, or also known as parent class, right? And the arrow is like this. But how do I implement this over here? So we use a reserve keyword, something called as extends, and BMW car extends car class, right? Now, whenever BMW extends a car class, all the instance variables and instance methods of the base class will be inherited by this car, right? Now, BMW car may have its own feature which may not be present in the car class. For example, let's say I will say BMW car has something called as digital meter, right? So what BMW did then? BMW has defined digital meter as its own method in its own class, right? Apart from the methods which it has inherited, right? Whereas if you see this mileage method, right? Now this mileage, this 12 kilometer per liter mileage may not be applicable to a BMW car, right? It might be giving maybe something called as 8 kilometer, right? Just because it is a higher cc car, right? So in this case, guys, whenever, just just keep this word, sorry, just notice this word. So whenever subclass basically implements the same method as that of a base class, then this concept is called as overriding basically, right? So I'll just specify this method as a overridden method. So if you see this green arrow, right, it says that this is a overridden method of the base class, right? And what is the purpose why BMW car was overriding? The reason is very simple, right? Because the behavior of this method mileage is different for BMW car, so it cannot of course go ahead with the base class. That's the reason it has preferred overriding the method, right? Understood? Okay, just a second, let me resize this. Okay, now the way it can override the method, similarly of course this BMW car, the way it was having its own method called as digital meter, it can also have its own variable. For example, I'll say string, let's say factory location, like this. Okay, and let let's create some meaningful code so that when we execute this code, we'll see some good output. Okay, so BMW, let's say this is DG meter, right? Now let's try to invoke this code. Okay, now I can write down the main method either in the base class, or I can write it in the BMW car as well, or I can altogether create another class as well, let's say test car, and I can also create a main method over here. Doesn't matter, main method can be anywhere. We can invoke the objects from anywhere in fact, right? So let's say if I create an object of car, so I'll say new car. This is how we create the object, and I'm creating a reference called as C1, right? Now if you see here C1 dot, if I do, so you will notice C1 has access to the instance variables of course the car class, right? For example, string, model, name, and of course start and mileage, right? So if I say here C1 dot name, or let's call the method C1 dot start, okay, C1 dot mileage, correct? Now even before that I'll say C1 dot name, and I'll say this is Hyundai car, correct? And then I'll say guys C1 dot model, and the model is, let's say, I10, like this. Okay, so let me quickly say here car start, like this, plus name, and I'm going to say here like this is 12 kilometers per hour, right? And if I execute this code, of course what will happen guys, this method gets executed. And now let me do that quickly. So if you see car started, Hyundai car average is 12 kilometers per hour, correct? Per liter, sorry. Okay, now let's create the object of, let's say for example, BMW car, right? Like let's say BC1 new of BMW car 1, like this. So in this case I'm creating a object of child class, right? So of course this child class is inheriting the methods of the base class. So this BC1 will have access to, of course, the variables which were declared in base plus child, right? Let me say BMW, for example. I'll say BC1, let's say model, let's say the model is X700. Okay, I'll say the factory location is, let's say, some Mumbai. Okay, and let me call now BC1 dot start, BC1 dot mileage, and BC1 dot, for example, BC1 dot, let's say, digital meter, right? So if you see here this name and model, these two are the inherited variables from the base class, whereas this is also a method of a base class, right? But whereas this mileage is of course a method of base class, but it's overridden in child class, right? So whenever we execute this code, it is always going to call the overridden method here, right? Whereas this digital meter is a method of BMW car, correct? Let me save this program and execute. So if you see here, let me put a line here, something called as like this, just a second. Okay, now, right? So if you see here, it has set the variables first, right? We have set the variables. Then if you see bc1 dot start, so it has called a method from your base class. Then I'm saying mileage, so it has called mileage overridden method of BMW car class. And then I'm calling the digital meter basically, right? So this is how guys Java supports inheritance concept, right? But just keep this in mind that Java doesn't provide multiple inheritance. Meaning, okay, meaning let's say I have a class called as A. Let's say class B is extending class A, right? And let's say C is extending class B, right? So I cannot say something called as C extends b comma c, right? So this is not allowed Java, right? This is as in multi-level, multiple inheritance is not allowed in Java, right? Whereas guys, multi-level is very much possible, meaning C can extends B and B can extends A, like this. Okay, so I'm saying B extends A and C extends B. So multi-level is possible, whereas multiple inheritance is not allowed in Java. Okay, got it what I meant here? Okay, of course multiple inheritance is possible in the form of interface that we'll see in the upcoming in some time, in fact. Okay, understood now. So guys, a couple of important things we have learned here is that what is overriding. So overriding, as I just explain you. Okay, so same method implemented in, yes, what implemented in child class is called as overriding. Okay, for example, mileage, as we discussed, mileage is the method of base class, but BMW car wanted to have it in a different way. BMW wanted to implement that in a different way, so BMW has overridden mileage method of the base class. Basically, that's the reason it is known as overriding, basically. Understood? Okay, okay, let's move on. Right now, guys, if you see here, let me show you another example of inheritance. For example, I'll create another package. Let's say inheritance 2. Okay, fine. Now let me show you another example. Let's create a class in the name of animal. Okay, let's say this animal has two methods. Let's say eat. Okay, and I'm going to say sys out, let's say eat, let's say animal eat. Correct. Similarly guys, there's another method, public void, let's say sound. Okay, and again I'm going to say here animal sound, right? Let's say there's a name to an animal like this. Okay, now what I will do here, I'll create another class with the name of tiger, right? Now tiger is the animal, so of course I'm gonna say extends animal. Okay, now we know that sound of a tiger is different, whereas see, all animals, of course, they do eat, right? But sound of all animals is not same. So this sound method is not applicable to the tiger as it is, right? So what I'm going to do here, I'll say public void sound, okay? Because sound of animals, the sound of tiger is different, and I'm going to just say here tiger sound, right? Again, if you see this icon, it means it's a overridden method. So just say here override. This you need not write this annotation, okay, but if you write, the readability of your program will be increased, right? Now tiger has some additional feature. Let's say tiger, for example, tiger running speed, okay, which is very specific to this animal, right? So I'm gonna say here speed. Just instead of this, let's make as tiger speed, right? And I'll put here, let's say, tiger speed, like this. Now let's say guys, we have another animal called as elephant. Okay, so again this elephant, let's say, has public void, let's say, sound method. Okay, so I'll say sys out and sound like this. Okay, okay, again guys, so let me implement the inheritance first. So extends, let's say, animal. Okay, so this sound is a overridden method, so I'm gonna say here override, and let's say I'll say public void, let's say elephant, let's say method 1, like this. Okay, maybe we can say here elephant weight. Okay, and let's say guys, again I have sys out, this is elephant weight, right? So if you see here what I did exactly, so I have a simple class animal, okay, and I have two other classes, okay, who are basically extending this animal class, right? So let me say something like this. So these are the extending classes, right? So just a second. Okay, the arrow should be like this, right? As I mentioned, correct? Because yeah, so this is animal, yeah, so this is animal, and this is your tiger, okay, and this is your elephant. Okay, now as I mentioned, here all animal has these two methods, eat, and you have sound basically. Okay, like this. Okay, yeah, so just a second, I'm trying to put the curly brackets here so this looks good. Okay, eat and sound, right? Now as I said, tiger has a different sound, right? So what tiger class did, tiger has overridden this sound method. At the same time, okay, elephant also has a different sound, so elephant also overrode the sound method, right? Now tiger may have its own method as well, for example speed, as we discussed. For example, elephant has weight, right? So this is how we created a structure. We created a inheritance between these three classes, right? Tiger extending animal, elephant extending animal. Now guys, as we know here, as I discussed just now, now I can of course create, let's say, animal like this. Okay, I can create a object of animal like this, right? So this is like creating a object of base class, right? And of course the reference is also of base class, right? Now we also know that we can create object of child class and child class as well, right? For example, I'll say tiger t1 equals to new of tiger. What happens in this case guys, this t1 will have access to the methods of tiger plus the inherited methods of animal. Of course the sound is a overridden method, so it gets the preference here, correct? So if I say t1 dot sound, it will always call the overridden method of tiger class. Now there is another way. For example, object of child class with object of child class with parent reference, meaning, for example, animal a2 equals to new of tiger. So if you see here, okay, I'm creating an object of new tiger but giving the reference of animal, right guys? Try to understand this. This is a very important concept. So I'm creating the object of tiger but giving the reference of animal. So in this case, this a2 guys will only have access to the methods of your base class, the referencing class basically, right? So who is referencing here? Referencing is of animal. So this a2 will always have access to the animal methods only, but the origin methods will be called as that of child class. So here a2 will always be called from animal, whereas a2 sound will be called from your tiger class, correct? Whereas the speed, this a2 cannot access the speed method because we had given a reference of animal, correct? Right? I hope you've understood, right? Similarly, again I can do something called as animal. Let's say now let's say I have simulated the sound of tiger. If I want to simulate the sound of elephant, I can simply point this reference to this elephant object and I can simulate the sound of elephant as well, right? Let's try to do this here, right? So I'm going to say here new class, let's say test sound, right? From here I will try to invoke all the objects. So I'll create a main method over here, correct? Now let's try to create, as I mentioned, I'm gonna create reference of animal but object of child class like this. Okay, so A should be capital, it's case sensitive, I'm sorry, right? So in this case, how do you read it? We have created object of child class tiger and given reference of parent class. What is the parent class here? Is it's animal basically. Understood? Yeah. How do you read it? We have created the object of child class and given the reference of parent basically. Correct. Let me pull this down like this. Correct. So in this case, just a second. In this case, this A1 will only have access to the methods of animal class, and of course the preference would be given to the origin methods of tiger, right? So for example, when I say a1 dot eat, so this is the method of animal, of course it would be called from here, whereas a1 dot, if I say sound, again sound is also a method of animal but it is overridden in the tiger. Okay, so this will call method of tiger class, right? Origin method of tiger class, correct? Whereas there was another method of tiger called as speed, but as I mentioned, that cannot be accessed with this type of referencing. Okay, so if I execute this code, let me show you. See, so eat is called from animal, whereas sound is called from your tiger class, right? Now I can, so my, let's say the so let me show you pictorial. So for example here, so what I did here basically, I am having simply a reference, okay, whose name, and this reference guys, okay, let me show you. This reference is of what? Animal class, and its name is, let's say, A1, right? Now I have made it point to the tiger class basically, correct? So if you see here, now I am pointing it to tiger, correct? Like this. Okay, now once my tiger work is done, what I'm gonna do that I'll point it to now elephant, right? So in that case, guys, this reference, this A1 is no more pointing to tiger, and now it will start pointing to elephant, correct? Right? So the same stuff we'll try to do here. Okay, so I'll just create the reference first here. Let's say A1 like this, and now at line number 8 I'm pointing it to tiger, right? Because I want to simulate the tiger sound. Now my tiger work is done, so now guys I will point it to elephant, correct? And I'll say here A1 dot, again I'll say A1 dot eat, A1 dot sound. So I am able to simulate the sound of elephant here, correct? So if you see again, elephant sound. So in this case, if you see here, again I was creating an object of elephant, but I was giving a reference of animal, right? Again here also, if you see object of tiger, but giving the reference of animal, right? So this A1 guys is taking, if you see, A1 is at times acting as a tiger, and at times it is acting as elephant, right? So this A1 object is taking basically multiple forms, correct, isn't it? So this phenomenon, this concept in Java is called as polymorphism, correct? Object taking multiple forms is known as polymorphism in Java basically, correct? Now polymorphism guys is of two types, okay? Static polymorphism and dynamic polymorphism, correct? Okay, so if you see this example, now your JVM knows this behavior at runtime. At this point of time, it doesn't understand which method it is calling. This sound method, whether to call this sound method of a base or a child class, it doesn't understand that. It detects this behavior at runtime, and that's the reason this type of behavior in Java is called as dynamic polymorphism. Whereas, if you remember the concept of overloading, okay, we overloaded methods, we overloaded constructors, right? So that type of behavior is called as static polymorphism, because your JVM knows this particular behavior at compile time itself, right? So that's the reason it's called as static polymorphism, whereas this tiger and elephant example is known as dynamic polymorphism. Okay, so a object taking multiple forms is nothing but polymorphism. Poly means multiple basically, right? I hope you have understood this concept. So now we're gonna talk about, after this we'll talk about what do you mean by interfaces and abstraction basically, right? All right guys, thanks for watching this video.